These are the practice problems for Lesson 1, Number Puzzles. And in this first problem, you are given the different fractions of a book that Tyler read during the week and asked to figure out how many pages are in that book. And so on Monday, Tyler read 2/15 of the book. On Tuesday, he read 1/3 of the book. On Wednesday, he read 2/9 of the book. And then on Thursday, he read 3/4 of the remainder of the book. And then he still had 14 more pages to read on Friday. So you're supposed to figure out how many total pages are in the book. And so what you have to realize is that 3/4 of the remainder, if you can figure out how many pages that is, then that's a fraction of the whole book. That 3/4 plus the 1/4 plus these 14 pages is a fraction of the whole book. And once you know what fraction that is of the whole book, you can figure out how many pages there are in that book. So to solve this problem, I know that I'm going to have to figure out what fraction of the book he read on Monday, Tuesday, and Wednesday combined. So I'm going to have to add 2/15 and 1/3 and 2/9. I'm going to have to add all those parts together, and then that will tell me what fraction of the book remains. So I'm going to have to figure out some factors of 15. So 3/4, let's just go back for a minute. So 3/4 of the remainder of the book he read on Thursday. So remember that those 14 pages that he has to read on Friday is 1/4 of the remainder of the book that he had to read on Thursday. So that's the key. So once we know, actually we can tell what that remainder is right now because it's just 4 times 14. This 14 pages is 1/4 of the remainder. So the remainder, that remainder is 56 pages, 4 times 14. But the key, the issue is that 56 pages is what fraction of the whole book. So I'm jumping ahead just a tiny bit. So I need to figure out how to add 2/15 plus 1/3 plus 2/9 together. That means I have to think about factors of 15, 3, and 9. I don't know if I need the 4th or not. And I need to think about common multiples so I can figure out what a common denominator is. Well, the factors of 15 are 3 and 5. And the factors of 3, of course, are 3. So 15 is both a multiple of 15 and a multiple of 3. So now what about the 9? Well, I need to include a factor of another factor of 3 in here to get to the 9. So 3 times 3 times 5. So this is 3 times 15. And then also 5 times 9. And we also have the factor of 3 in here. This is using prime factorization to figure out the common multiple or the common denominator. They don't teach that anymore, but this is what we used to teach in 6th grade a lot. So anyway, the common denominator or common multiple of 15, 3, and 9 turns out to be 45. So 3 times 15 is 45, and 5 times 9 is 45, and 15 times 3 is 45. All right, so now this drawing in the beginning is not to scale. These parts are not the proper relative sizes. It's just, I'm just making sections so I can put some numbers in there to move towards the answer. And I said a moment ago that we know that this 1/4 of the remainder is 14 pages. That means that that 3/4, or I'm sorry, the entire remainder is 56 pages because it's 3/4 of the remainder are 42 pages. 3 times 14 is 42, and so you combine these two together and you get a total of 56 pages. Another way to think about it is just 4 times 14 pages. So we know that this is 56 pages. So what fraction of the entire book are those 56 pages? Well, this piece right here is 2/15 of the book. This piece right here is 1/3 of the book, 2/9 of the book, and this is going to be the remaining fraction. After I figure out what fraction all of these pieces are, this is going to be the remaining part. So 2/15 plus 1/3 plus 2/9. I have to add all of those together. So 2/15 is the same as 3 times 15 is 45. 3 times 2 is 6. So 6/45. 1/3 is 15/45, so 15 times 1 and 3 times 15, and 9 times 5 is 45, and 2 times 5 is 10. So it's 6/45, 15/45 plus 10/45 equals a total of 31/45. So that makes this part of the book right here 31/45 of the whole book. That means that this piece right here is the remaining fraction. It is 14/45. So this remaining part is 14/45 of the book, and that equals 56 pages. All right, so how do I use that to figure out what the total number of pages of the book are? Well, if I can figure out what 1/45 is, then I just multiply that number by 45. And so 1/45 is going to be these 56 pages divided by 14. This is 14/45. I want to know what 1/45 is. So the 56 pages divided by 14. So now what I'm doing is multiplying by the multiplicative inverse of 14/45, which is 45/14. So I'm going to divide by that 14. That's going to tell me one of these parts is equal to how many pages, and it turns out that it is equal to 4 pages. And so now I just multiply 45 times 4 pages. 1/45 of the book is 4 pages long. I'm going to go over this again in another way in just a moment, so just hang in there. 4 pages of the book is equal to 1/45. That means the whole book is 45 of those 4-page parts. 45 times 4 is equal to 180 pages. So the book is 180 pages in length. So let's go over this again. So 14/45 of the book is equal to 56 pages. So this section right here is 14/45 of the book. That is equal to 56 pages. Then 1/45, one of these pieces, is equal to 56 divided by that 14. That's going to give you what one of those parts is. So we have 14 parts right here, equal 56 pages. What does one part equal? Well, one part equals 56 divided by 14, which equals 4 pages. So 1/45 of the book is equal to 4 pages in length. And then you multiply by 45 to get the entire length, the entire number of pages of the book. So 1/45 of the book is equal to 4 pages. So that means that the book is equal to 45 times that 4 pages. So that's multiplying by the multiplicative inverse of 1/45 is 45. So 45 times 1/45 is equal to the whole book, 45/45. So then you have to multiply the 4 pages by that 45 to tell you how many pages are in the book. And this is a little bit tough, but the drawing is helpful in sorting out how I'm trying to explain this. The key for you guys to learn this is to try to explain it to yourself, try several different ways, and work through it. Now, I want to review just for a moment how you learned division in very early grades, probably 3rd grade. And you learned fact families. So let's look at the column on the right just for a moment. So you learned that if you had a number that was the product of 2 factors, so 2 times some number equals 6. So you learned that fact family. 2 times 3 equals 6, 3 times 2 equals 6, 6 divided by 2 equals 3, 6 divided by 3 equals 2. So you learn that fact family. So then if you're given 2 times some number equals 6, what is that number? And so then you just visually figured out and you learned and understood that, well, 6 divided by 2 then is equal to 3. And that's the same as multiplying 6 by the multiplicative inverse of 2. So 6 times 1/2 is the same as 6 divided by 2. So here's the 6 divided by 2. That's the same as 6 times 1/2. So 1/2 of 6, you all know, is 3. So x is equal to 3. 3 times 1 is equal to 3. So you take that same idea to this part on the left here. I just want to go over why you multiply 14/45 of the book by 45/14, which is the multiplicative inverse. So I did go back to the equation for proportional relationship. Don't really need that, but it just shows you that everything that we're doing can go way back into your early elementary school understanding of math. So I have 56 equals two factors. One factor is 14/45. The other factor is b, the size of the book, the length of the book. So how do I figure out what the length of the book is? I divide, or I multiply by the multiplicative inverse. I divide by 14/45, which is the same as multiplying by the multiplicative inverse of 14/45, which is 45/14. So now look what you're doing. So this is the same as over here. How do I figure out what x is? I'm going to multiply by the multiplicative inverse of 2. How do I figure out what b is? I'm going to multiply by the multiplicative inverse of 14/45. So now look what you're doing. You're taking those 14 parts, dividing by 56 by those 14 parts. That's going to tell you how much is in 1/45. That's what we did on in the last slide. We took the 56 pages, divided it by the 14 parts. That tells you how many pages are in one of those 14 parts. That's 1/45. Then multiply that by the 45 to give you the total number of pages. So the number of pages in the book B is equal to 180 pages. This takes time, it takes practice, it takes effort to continue to go through this, try different examples, and go through this kind of thinking. And we're certainly going to continue to go through this during the course. All right, so now I'm going to redraw the beginning drawing, but I'm going to make it more to scale. So these sizes are more appropriate as far as their relationship to the other pieces. So we have 4 parts. One part is 6/45, so this is 6 units. Another part is 15/45, so this is 15 units. Another part is 10/45, so this is 10 units. And the last part is 14/45, so this is 14 units. Now it gets a little bit confusing. I probably would have chosen different numbers if I rewrote this problem. This is 14 parts, or 14/45. That is unrelated to these 14 pages. And it probably is related in some way, but this 14 pages, that 14 is a different 14 than this 14/45. We really don't need the 14 pages anymore, because we know that these 14 parts are equal to a total of 56 pages. So now once we've used the 14 pages to figure this out, we can ignore that. We don't need that anymore. So now we know that 14/45 is equal to 56 pages. So this piece right here is 56 pages in length. So I want to know what 1/14 of that is. What is one of these parts, which is 1/45? I divide the 56 by 14, and that tells me that 1/45 is equal to 4 pages. So 1/45 of the length of the book equals these 4 pages right here. So once I know that, so 10 parts, each of the parts are equal to 4 pages. So 10/45. Oh, let's go back for a second. Remember, this is 3/4 of the remainder of the book right here, and this was 1/4 of the remainder. And that was the key. This 1/4 of the remainder equal to 14 pages enabled us to figure out what this whole piece was right here, which is equal to 56 pages. All right, so 10/45 are going to be equal to 10 times 4 pages for each of those parts. You have 10 of the parts, so it's equal to 40 pages. 15 parts is 4 pages for each part. 4 times 15 is equal to 60 pages. And we have 6 parts, 4 pages for each of those parts. So 4 times 6 is equal to 24 pages. So here are the different number of pages that Tyler read on Monday, Tuesday, Wednesday. On Thursday, he read 42 pages. On Friday, he had 14 pages left to read. This is problem number 2. So Claire asks Andre to play the following number puzzle. So pick a number, add 2, multiply by 3, subtract 7, add your original number, whatever number you picked in the beginning, add that original number, and Andre ends up with a final result of 27. So what number did Andre start with? So here are the steps written out algebraically. So pick a number x, add 2, multiply this value right here by 3. So you have to multiply the whole thing by 3. So 3 times x plus 2. Subtract 7 from all of this, and then add x back. So whatever x is, you add it back, or you add it again, and you end up with 27 as your answer. So to work backwards, you can't work backwards exactly, because if you say, okay, now I'm going to subtract this x, you don't know what you're subtracting. So you have to get these x's together in some way, and some single value that you can subtract from 27 to figure out what x is. So to do that, we're going to use the distributive property. So if this is 3 times x plus 2, if I have 3 x's plus 2's, then I have 3 x's, and I have 3 times 2 is 6. So 3x plus 6, sorry. Now subtract the 7 from that, add x, and that equals 27. So now I can combine the 6 and this negative 7. So you're going to add negative 7. That's going to equal negative 1, and I can combine this x with this 3x. So that's going to equal 4x. So now I can get this down to 4x plus 6 minus 7 equals 27. And 4x plus a negative 1. So remember, this is subtracting a positive 7. So that's the same as adding a negative 7. So you're going to use the inverse operation and use the additive inverse. The inverse operation is addition. The additive inverse is a negative 7. So this is the same thing. But it's just easier for me anyway to add 6 plus a negative 7 in the middle of this. So I'm going to add negative 1. And that equals 4x plus a negative 1 equals 27. So this is 1 less than 4 times this number. So this number then is 4 times this number is 28. So 27 is 1 less than that, because it's 4x plus a negative 1. So I have to add that 1 back. So that takes me from 27 to 28. So now I have 4x equals 28. So 4 times whatever number I chose equals 28. That means the number I chose was 7. So now I'm going to go through, I got a little bit tongue-tied in that, sorry. But now I'm going to go through some different ways of thinking about this. I could say, oh, we're done, we're finished. But I want to push the idea of trying to make a drawing of these problems to help you think through it, and just see different ways that you might try to solve it. That helps you figure out what to do if you run into trouble. Maybe you go down the wrong path or a more difficult path. Can you fight your way through it? Can you figure out how to get out of that? But first of all, let's look at this number puzzle in a little bit more detail. So I have 3 times x right here, and I have another x over here. That means I'm going to end up with 4 x's. Somehow, whatever I do, I'm going to end up with 4 x's. 3 times this x plus this x over here. I'm also going to end up with negative 1, because I'm going to end up with 6 right here. 3 times 2 is 6, plus a negative 7. So I'm going to add negative 7. So I'm also going to end up with negative 1. So I'm going to have 4x plus a negative 1 equals 27. So that is, in words, that is 1 less than 4 times the original number. Now what if you play around with this a little bit, and rather than 7, let's say that you use 8 as x. Well, what's 4 times 8 is 32. Or 9 as x. 4 times 9 is 36. And the puzzle gives you the relationship of 1 less than 4 times this number. Well, what's 1 less than 28 is 27. What's 1 less than 32 is 31. What's 1 less than 36? It is 35. And notice that all of these differ by 4. Because you're multiplying by 4 times 7 is 28. 4 times 8 is 4 groups of 8, but that's 4 times 7 plus 4, 1 more in each group. Or 4 times 9 is 4 times 7, you want to go back to the 7, plus 2. Or an extra 2 in each group. So that's going to be 8 different from 28. So there are some relationships here, and that's all I'm trying to point out to you. And so if it's 1 less than each of these numbers, so the final for this value, if you choose 7, it's going to be 27. If you choose 8, it's going to be 31. If you choose 9, it's going to be 35. All right, so to make a drawing of this problem, you just start out. I'm going to start at 0, and it says pick a number, that's x. So here's x right here. I don't know what it is. I'm just going to put it on the number line. And then I'm going to add 2 to that. And then I'm going to multiply that by 3. So I'm going to have 3 times x plus 2. So I'm going to have 3 of these. X plus 2, x plus 2, and x plus 2. Then I'm going to subtract 7. But I don't know where I am right here. I don't know what this value is. Whatever it is, I'm going to subtract 7 from it. Then I'm going to add x back, and I'm going to end up at 27. So at this point, I got stuck. I didn't really know how to use this diagram to help me solve the problem. And so what I did is I did do some more algebra to help inform me how to work through this diagram. And then the diagram helps me, again, work through how to solve the puzzle. So I'm going to go back and forth here a little bit. And again, I'm going into a little bit too much detail, but I think you have to see different ways of solving these problems and different struggles that people can have. Now, this on the left looks tough because it's really using quite a few fractions, and it's kind of a mess because I chose really the wrong path. It is a path that gets the answer. You get down here to the answer, x equals 7, but it's a more, let's say, a more difficult path. Not really the wrong path, but a more difficult path. I'm going to show you what happens if you choose to use the distributive property first. So on the left, I'm not going to use the distributive property. I'm going to say, well, I have 3 times some number plus x, and this equals 34. I can add a positive 7 to this negative 7 to make this 0. I add that positive 7 out here to make this 34. All right, so now I have 3 times x plus 2 plus x equals 34. If I decide, okay, I'm going to take 1/3 of this. I'm going to just look at x plus 2. I'm going to divide this by 3, so this becomes x plus 2. The thing to remember is if you choose to that path, then you have to divide each term. This is called a term. This is a term. This is a term. Now, this is not simplified, but it is a separate term than this x. And the 34, of course, is on the other side. That's also a separate item or a separate term in the problem. You have to divide each of those by 3. You can't just divide this one by 3, but you also have to divide this x by 3 and the 34 by 3 to keep everything balanced. If I'm going to decide I'm going to take 1/3 of 3 times x plus 2, I also have to take 1/3 of x and also have to take 1/3 of 34. So now I'm at x plus 2 plus x divided by 3 equals 34/3. So it gets a little bit tough, and you can just work through this. If you look at it and think about it, it becomes more understandable. So now I have x plus 2 plus 1/3 x. So x divided by 3 is the same as 1/3 x. This is multiplying by the multiplicative inverse of 3. Inverse operation is multiplication. Multiplicative inverse of 3 is 1/3. So it's the same as 1/3 of x. And that equals 34/3. All right, so I want to combine this x plus this 1/3 x. Well, this x is 3/3 x. Combine them together, you get 4/3 x. And that equals 34/3 plus a negative 2. I want to get these x's together, and I want to get this 2 onto the other side because I want to end up with x equals something. So I can add the additive inverse of a positive 2, which is a negative 2. I'm going to also have to add that additive inverse to this side. So that's where that negative 2 comes from. So 34/3 plus negative 2. Now, 3/4 of 4/3 is 1. So think about that for a second. I'm going to multiply by the multiplicative inverse of 4/3, which is 3/4. 3/4 of 4 things are 3 of those things. So 3/4 of 4/3 are 3/3. Well, 3/3 is one whole piece, one whole x in this case. So this becomes x. But I also have to multiply each of these terms by 3/4. So 34/3 times 3/4 plus a -2 times 3/4. Now this is long, detailed, hard, kind of, gee, I don't want to think about this. But if you try to fight through it, you'll begin to understand the math in more detail. And none of this is too hard for anybody to understand. You can all understand this stuff. So this equals 34/4. These 3's become 1. So 3/4 of 34/3 is 34/4. A little bit hard to visualize. Plus a -6/4. -2 times 3/4 is a -6/4. Combine these together. 34 plus a -6 is 28. 28 divided by 4, or 28/4, is equal to 7. Now that was tough. Now if I took a different path, a less difficult path, by simplifying this term right here first. So by simplifying, that means to get rid of the multiplication, to rewrite this only as addition. So that means 3 times x plus 2 means I have 3 x's plus 3 times 2 is equal to 6. So this ends up being 3x plus 6. It's using the distributive property. I have this x I have to add to it, and this had become 34 because remember I added this +7 to get rid of this -7. I have to add +7 to 27, that equals 34. This is a lot easier to deal with. So I have 3x plus x is equal to 4x. So I have 4x's, 3 times 2 is 6, that equals 34. So now I know what to subtract from this 34, which equals 28, and then 1/4 of 28 is equal to 7. So that told me in my drawing I have to look at the distributive property. I have to use the distributive property. So I have 3x plus 2. So I have 3 x's, I have 3 2's, and I have one more x out here. Well, that 3x plus 2 is 3 times x plus 2 is 3x plus 6. So this right here, 1x, 2x, 3x, plus 2, 4, 6. So 3 times x, 1x, 2x, 3x, plus 3 times 2, 2, 4, 6. Now this is 3x plus 6. And I'm going to add one more x to that. So that tells me out here, this is 4x plus 6. Well, how much is that equal to? Well, if I subtract whatever it is, if I subtract 7 from that, or I add -7, I'm at 27. So this is 4x plus a -1, because I added a -7 to the 6, brought me back to 27. So if I just add 1 back to this, I get rid of this -1. This is 1 less than 4 times the number. Well, I'm going to add that 1 back. This is going to be 28, and 4 times whatever x is equal to 28. That means that x is equal to 28 divided by 4. So 28 divided by 4 is 7. So here's the 27, and here's the 34 out here. I never did say that, but this gets you out to 34, and you can see that in that this is 4x plus 6, and that equaled 34. That's right here. 4x plus 6 equals 34, because when you added that 7 to get rid of this -7, this became 34. So this 4x plus 6 is out at 34. And if I subtract the 6 from that, I actually end up at 28. But the problem said to subtract 7. All right, so this is long, a little bit too detailed. Maybe I went into too much detail, but think about it, give it a shot, try to work through it. This is problem number 3, and in this problem there's a basketball game, and there are several players in that basketball game, and they score points in the game. And they score points, the number of points that they score is compared to or relative to another player's points, with the exception of May. In the end, they tell you how many points May scored. And that's going to be the key to solving this problem is no matter how many comparisons they give you in the problem, eventually they have to tell you the number of points that at least one player scored. And then you can use that to calculate back to figure out, in this case, how many points Elena scored. So that's the end. So you start out, Elena scored twice as many points as Tyler. So just draw an arrow. This is Tyler's number of points. And Elena scored twice that many. So draw 2 arrows. That's twice. That represents twice as many points as Tyler scored. Then it says that Tyler scored 4 points fewer than Noah. So Tyler plus 4 points equals Noah, or you can look at it as Noah is equal to, Noah is equal to Tyler plus 4 points, or you can look at it as Tyler is equal to Noah's number of points minus 4. So Tyler scores 4 fewer points than Noah scored. So here's Tyler, add 4 more points, you get to Noah, or start with Noah, subtract 4 points, and you get to Tyler. So they go back and forth. They are related in that way. And finally, they tell you that Noah scored 3 times as many points as May. So here's May. So Noah's the same length up here, but Noah scored 3 times as many points as May. And finally, they tell you how many points May scored. That's the key to solving the problem. They have to give you the number of points that at least somebody scored. So May scored 5 points. All right, so now you can work backwards. The question is, how many points did Elena score? So she's going to be X in the end. So May scored 5 points. That means that Noah scored 3 times as many points as that. So 3 times 5 is 15 points. Well, how many points did Tyler score? Tyler scored 4 points fewer than Noah. So Tyler scored 11 points. 15 minus 4 is 11. Well, then how many points did Elena score? Elena scored twice as many points as Tyler. So that means that Elena scored 22 points. Now, the idea is to turn these stories into equations and learn how to solve those equations. But it's always a good idea to include this diagram, this kind of diagram or some diagram of your own making. All right, so we're going to start out with Elena is equal to 2 times Tyler's score. So Elena, or E, equals 2T. 2 times Tyler's score equals Elena's score. Now we know that Tyler scored 4 points fewer than Noah. So we can replace Tyler's score with Noah's score minus 4 points. So this is the same as Tyler. So Elena scored twice as many points as Noah minus 4 points. So this is equal to Tyler, which is 4 points fewer than Noah. And then finally, we know that Noah scored 3 times as many points as May. So 3 times May is equal to Noah, so we can replace Noah's score with 3 times May's score. So now we have Elena is equal to 2 times 3 times May's score minus 4. This is Noah's score, and this is 4 points less than Noah's score. All right, and we know that May has scored 5 points. So 3 times 5 is 15. That's the number of points that Noah scored. 15 minus 4 is the number of points that Tyler scored, because remember, he scored 4 points fewer than Noah. So that's 11. And Elena scored twice as many points as Tyler, so 2 times 11 is 22. So going back and forth and figuring out what this single equation is the goal of these kinds of problems. This is problem number 4. And you're given an equation, you're asked which of these points, there are 6 points here, which of these points lie on a line that is a graph of this equation. In other words, which of these points are solutions to this equation. So I'm going to approach this 2 different ways. One is if I'm going to plot these points. So the word is plot, P-L-O-T. So when I place these points on a coordinate grid or a coordinate plane, that is called plotting the points or graphing the points. So I'm going to put all 6 of these points on this grid. I'm going to plot them or graph them. Then I'm going to look to see which of these points fall on a straight line. Now you can draw a straight line between any 2 points, but is there a line that you can draw through more than 2 of the points. And in fact, there is. This line you can draw through 4 of the points. So then if I can write the equation for this line and match that to this equation, then that says that they are equal. They are both equations for this line. So all 4 of these points then lie on the graph of this equation. All 4 points lie on the graph of, on the equation of the graph of this line. The question is it the same equation as this equation over here? All right, so the idea is to get both of these equations, the equation for this line and the equation that's given to you in this form, y equals mx plus b. And remember, m is the slope of the line and b is where it crosses the y-axis, called the y-intercept. So the first thing I can see easily is that the y-intercept is at -3. So you go from 0 to -3. So this point is 0, -3. So the y-intercept is -3. So I can replace b with -3 right here. So now if I can just figure out the slope, then I have the equation for the line. Well, the slope is how much there is a vertical change compared to a horizontal change. In other words, for every unit that this changes in the horizontal direction, how many units are changed in the vertical direction? So that's the change in y divided by the change in x. So in this case, it's 4 units in the y direction divided by 1 unit in the x direction. So 4 divided by 1 is 4. If I go over 2 units, then there's an 8 unit change in the y direction. So 8 divided by 2 is 4. If I go over 3 units, 1, 2, 3, then there's a 12 unit change. 4, 8, 12. 12 divided by 4, 12 divided by 3 is 4. So in each case, as you divide the change in the y direction by the change in the x direction, you get an answer of 4, which means for every single unit change in the x direction, there's a 4 unit change in the y direction. So 1, 4, 1, 4, 1, 4. So it's 4 divided by 1, 4 divided by 1, and 4 divided by 1. So the slope is 4. So the equation for this line is y equals 4x plus -3. So if you're going to graph this line, you place the point at -3 and then just figure out a slope of 4. So you go over 1 point up 4, or 1 unit up 4, and you get this same line. Now, this looks pretty good. Here's 4x, here's 4x, here's a 3. This is -3, and here's a y, and here's a y. So we'll see if we can work with this equation now and get this in the same form as this equation. So I'm going to rewrite this y. This is subtracting a positive y. So I'm going to rewrite subtraction as addition. It's always a good thing to do. Rewrite the operation of subtraction as addition. So you would use the additive inverse. So the additive inverse of a positive y is -y. So now if I want to get rid of that, which I do, I want to actually get the y over on this side. I want to get the y as a positive a positive y. So I'm going to move it over here. So I'm going to add a positive y to this negative y. That becomes 0. So what I'm doing is using the additive inverse now. So y plus a negative y plus a positive y equals 0. But you also have to add that positive y to this side. So this becomes 3 plus positive y. This becomes 0. So now we have 4x equals 3 plus a positive y. All right, so I have positive y here, a positive y here. 4x is on this side, 4x is on the opposite side here. And now it's just this -3 and this positive 3. So if I move this positive 3 over to the left side, so I have, right here I have a positive y plus 3 equals 4x. That means that 4x is y plus positive 3. So y is going to be 4x minus that 3. So I have to take that 3 away or add a -3. So a positive 3 plus a -3, this becomes 0. So I'm going to add the additive inverse. And so on this left side, then you end up with 4x plus negative 3. So positive 3 plus a negative 3, add the additive inverse, and that negative 3, then you have to also add to the left side. So these two equations are equal. They're just switched. The y is on the right side, the y is on the left side. This is the same as this part. So you can take them and switch them over the equal sign, and they are the same equation. So that proves that these 4 points lie on a graph of this line, and they are solutions to this equation. So now what we can do is take each of these points, so A, C, D, and E, A, C, D, and E, and plug each of those points into this equation and see if they in fact do equal 3 on the left side, which is what the right side is equal to. So for A, this is 4 times negative 1, so x is negative 1, minus y, which is negative 7. So you replace those coordinates, and you end up with a negative 4. 4 times negative 1 is negative 4 plus a positive 7. So this is the inverse operation and the additive inverse. So I'm changing it to adding the additive inverse. So inverse and inverse. So the inverse operation, the additive inverse, is a negative 4 plus a positive 7, and that equals 3. So 7 minus 4, you find the difference of the absolute values. 7 minus 4 is 3, and there are more positives, so this ends up being a positive 3 right here. So 3 equals 3. So A is in fact a solution. B is not. So when we figure this out, we should end up with something other than 3. So 4 times 0 minus 3, so y is 3. 4 times 0 is 0, plus a negative 3. So you add a negative 3, that equals negative 3. Well, negative 3 does not equal 3. So this one does not work. C, 4 times 3/4. So x is equal to 3/4, y is equal to 0. So 4 times 3/4 minus 0, so y is 0. So 4 times 3/4 is 3. These 4's cancel out, and you're left with the 3. 4 times 3/4 is 3 minus 0. Well, 3 minus 0 is 3. So 3 equals 3, so C works. D, 4 times 1 minus 1, y is equal to 1, x is equal to 1. 4 times 1 is 4, minus 1 is 3. So D works. 3 equals 3. E, 4 times 2, x is 2, minus 5, y is 5. 4 times 2 is 8, minus 5 equals 3. 3 equals 3. E works, and F, of course, does not work. X equals 4. 4 times 4 is 16, minus y is negative 1, minus a negative 1, so that's the same as adding. Inverse operation is addition. Additive inverse is a positive 1. 16 plus a positive 1 is 17. 17 does not equal 3. So F does not work. So we showed which of these points are solutions to this equation, or lie on the graph, the line of this equation, by showing that this equation is equal to the equation for this line, and also we plugged each of the x coordinates and y coordinates into the equation and proved that they are equal to 3. This is problem number 5. A store is designing the space for rows of nested shopping carts. Each row has a starting cart that is 4 feet long, followed by the nested carts. And it tells you that 0 nested carts means that there's just the starting cart. Store measures a row of 13 nested carts, and that's 23.5 feet, and 18 nested carts, that's 31 feet long. So this is what nested carts looks like. So when you take carts and you slide them one on top of each other, that's called nesting. So these are nested carts. So 0 nested carts, this cart right here. The first cart is 4 feet long. And then the next cart, I'm going to show you how you calculate this in a moment. They want to know what the length is of each nested cart that's added on, and that answer is 1.5 feet. So we're going to go over how you calculate that in just a moment. So you add one nested cart. So this is one nested cart to this point right here. So 2 total carts, but 1 nested cart. And this is 2 nested carts. So again, the number of carts, the number of total carts is 3. The number of nested carts is 2. That's going to make a difference as we go through the problem. And so if you have 13 nested carts, now remember that's a total of 14 carts. They just want you to look at the 13 carts that are nested. That equals 23.5 feet. I'm sorry, this includes the 4 feet in the beginning. So this is 23.5 feet. And then you go out to 18 nested carts. This again includes the 4 feet in the beginning, but 18 nested carts gives you a length of 31 feet. So to figure out how many feet per each nested cart, you just go past the 4 feet somewhere. Go out, and they went out to 13 nested carts to 18 nested carts. This means I add 5 carts. How many feet do you add for those 5 carts? Well, you add 7.5 feet. So how many feet is that per cart? That's 7.5 feet divided by 5 carts. That equals 1.5 feet per nested cart. I should put the word nested in here. So 1.5 feet per nested cart. So that's how many feet get added. Now notice, when you calculate the slope, if you have an x column and a y column, or an x coordinate and a y coordinate on graphs, the way that you calculate the slope is what's the change in the, let's do the y direction first. What's the change in the amount of y, or in the y direction, compared to the change in the x direction? Well, the change in y is 7.5 feet. So that's 31 minus 23 and 5/10. That's 7.5 feet there. And that is compared to the amount of change in the x value. So the x value is 18 minus 13 is 5. So this is just like figuring out the slope. So the change in x is 5, the change in y is 7.5. So 7.5 divided by 5 is 1.5. So 1.5 feet per nested cart. That is the slope to the graph, which is what we're going to look at right now. So I'm going to put the number of nested carts on the x-axis and the number of feet on the y-axis. Well, if I have 0 nested carts, that starts out at 0 nested carts, that starts out at 4 feet. So this is going to be a point right here, 0, 4. And then when I had 13 nested carts, that's 23.5 feet. So this point right here is 23.5. And when I had 18 nested carts, that measured 31 feet. So that point 31 feet is right here. Notice these are 3 feet each. 0, 3, 6, 9, 12. So you have to realize that this is 1/3 of the way. 31, 32, 33. And 23.5 is, this is 21, 22, 23. You got to go up a little bit more to imagine where 23.5 is. All right, so the slope. So again, you could draw the slope triangle if you want from this point to 18 on the x-axis, and then 18 to 31. So the change along the y-axis is 31. That 31 minus 23.5. So how much is this changing along the y-axis? It's changing 7.5 feet. And how much is it changing along the x-axis? That is this 18 minus this 13. So 18 minus 13 is 5. So it's changing 5 units along the x-axis, 7.5 units along the y-axis. So that is 1.5 units per change in the y direction per 1 unit change in the x direction, which is 1.5 feet per nested cart. Now remember, go back a long time ago, we took that slope triangle, we slid it down to here by subtracting 23.5 and by subtracting 13. Subtract 13 to go over here, subtract 23.5 to slide it down to here, right here. All right, and they're going to ask you, so for feet increase, 1.5 feet for every one nested cart added to the row. That's what the slope means. And now they're going to ask, well, what if you have 43 feet in that row? How many carts is that equal to? And I'm going to tell you the answer. The answer is 26, because I can extend this line out and go up to where 43 is and go over to the x value for a y value of 43, and you're going to see that it lines up with 26. So it's 26 nested carts. I can also use the equation. We can write the equation to this line. We know all the parts. We know the slope is 1.5x, or 1.5, and we know that the y-intercept, where it crosses the y-axis, is 4. And so now I can just plug in, I can check to see if this answer of 26 is in fact exactly 43 feet. So I plug 26 in here for the x value. So it's 1.5 feet for every 26 carts, I should have said, 26 nested carts. So it's 1.5 feet for every nested cart. I have 26 of them. So 26 times 1.5 is 39 total feet. And plus I have 4 feet with the starting cart. So 39 plus 4 is 43 feet. So it's just going back and forth. Now this is the answer to the question. I'm giving that to you first. You have all the information to figure it out. But this point right here is at 26 nested carts and 43 feet. All right, and so it says, how much does each nested cart add to the length of the row? Explain your reasoning. So I just restated what I've said earlier. Each nested cart adds 1.5 feet to the row. It's 1.5 feet, and the slope is the slope of the line. The slope equals the change in feet, 1.5 feet for each unit change in nested carts. So 1 unit is 1 nested cart. That equals 1.5 feet. And how you calculated that, I showed you earlier. The store design allows for 43 feet for each row. How many total carts? Now this is going to be total carts, not just nested carts, but the total number of carts fit in a row. Well, 0 carts is 4 feet. X carts times 1.5 feet for the nested carts. Well, if I have 43 feet, I need to subtract that 4. So now that gets me at 39 feet. I need to subtract the 4 feet for the beginning cart. That's 39 feet. And how many carts is that 39 feet equal to? Well, 1.5 feet for each cart. So I divide 39 by 1.5, and you get 26 carts. So 39 feet divided by 1.5 feet per, and I should have put nested here, per nested cart. So that gives you 26 nested carts. But then you have to remember, add that 1 beginning cart. So that's a total of 27 carts. So don't get fooled. It's not 26 carts. It's 26 nested carts plus 1 more beginning cart gives you a total of 27 total carts. All right, let's use the equation. So y equals mx plus 4. We did that earlier, but let's just check it one more time. So they're giving you 43 feet. So now they're giving you the y value. So what you're going to end up doing is multiplying 43. We're going to get rid of the 4 first, but then you're going to end up by multiplying by the multiplicative inverse of 1.5, which is 1 over 1.5, which is the same as dividing by 1.5. That's why this stuff gets confusing. All right, so if I have the number of nested carts plus 4 equals the number of feet for the total number of feet, then to get the total number of carts, I have to subtract that 4. So it's going to be 4 feet less than 43. So 43 minus 4 is equal to 39. And that's going to be the total number of feet for the nested carts. So how many nested carts is that? Every time I take out 1.5 feet, that's 1 cart. So that's 39 divided by 1.5, which is the same. So now algebraically you say either divide by 1.5 or multiply by 1 over 1.5, which is the multiplicative inverse. And I like that better, actually. I like multiplying by 1 over 1.5, which is the same as dividing by 1.5. that equals x. That equals the number of carts, and it's the number of nested carts. Don't forget that. 26 nested carts is equal to 39 divided by 1.5. What are you doing here? You're taking 1.5 feet out each time. 1.5 feet is equal to 1 nested cart. How many times can you do that? You can do that 26 times. But then don't forget, you have to add that 1 cart at the beginning to give you a total of 27 total carts.